This is going to be your first of two videos for today's notes. In the first video, we're going to look at direct, inverse, and joint variation and some problems that go with them. The second, we'll look at some application problems from your practice packet. Good way to remember direct variation is direct proportion. So what that means when we get later into this is we're going to be setting up proportions. A direct variation is a linear relationship So if you think linear, we're thinking y equals mx plus b. But this is going to be where b is equal to 0. Now instead of using m, we're going to use k. K is a variable that we use for what's called a variation constant. So it's the same thing as a linear, like it would be y equals mx, technically plus 0, but we're throwing k in there. We're actually going to solve these for k. So I'm going to solve this for k. It's going to be k is y over x. And that's what we're really going to be using when we set these up later on. So the key that we're looking for in the wording in these is it says if y varies directly as x. So you want to underline that. That means we're going to be looking at direct variation. So what we're going to be doing is we're going to be setting up a proportion, y over x equals y over x. And then we're going to plug into that proportion. Now be careful because sometimes the variables might be squared or cubed or something like that. So in this first one it says if y varies directly as x and y is 9 when x is negative 15. So we can fill that into the first half. And then it says find y when x is 21. So we don't know y. Set that equal y over 21. Once you get this set up, it's just as easy as solving your proportions that you've done before. You'll do 9 times 21 equals negative 15 times y. And that's really it. It may get a little trickier like the second question down below. This one says y varies directly as x squared. So when you set this up, we want to do y over x squared instead of just y over x. Once you have that set up correctly, again, you're going to fill in the numbers. So y is 5 when x is 2. And then when y, or find y when x is equal to 6. So we're going to do y over 6 squared. So I skipped a couple calculating steps there. You technically could go right through to the final answer from your setting up of your proportion. So that's direct variation. It's similar to just solving proportions like you've done in Algebra 1 and before that. Second type is bringing us into this next unit is called inverse variation, and that's going to actually be a rational function, which is the unit that we are now currently in. And we're going to be doing graphs of these later on, so I'm going to hold off on that for now. In this case, it's similar in terms of the type of proportion. It's like an inverse proportion. We're going to multiply instead of divide. So rational functions are usually functions where you have division, which is the second one that I wrote there. We're actually going to use the first one where we're going to multiply. As how we're going to set up our inverse variation problems. So to determine if you're doing inverse variation, you're looking for the keyword if y varies inversely as x. So this is just plain y and x. I'm going to write out y times x equals y times x. Now really the order does not matter because you're multiplying, so that's fine if you set it up either way. So it says y equals 4 when x equals 12, so we'll plug in 4 times 12. And then it says find y when x is 5. And again, I skipped over a little bit on the solving steps there, but really all you have to do is multiply the two numbers on one side and then divide it out for your solving. Again, just like before, this could get a tiny bit more complicated because the next one says y varies inversely as square root of x. So instead of doing y times x equals y times x, you're going to do y times square root of x equals y times square root of x. And then we'll just fill in from there. So always be careful to make sure you fill into what you're given. This one says find x when y is 4, so make sure you plug it into the right spots because both situations you would have a perfect square, so that would work out. Forgot the square root there for a second, so hopefully you'll get a chance to fix copying that. Now we end up getting 2 is equal to the square root of x. To finish solving, you're going to want to square both sides. And you can always check these like any other equation by plugging back in. Now our last one, I know this video is a little bit long, so just bear with me. You can pause it if you need to take a break for a second. Our last one is called joint variation, and it's kind of like a combination of the two. It's going to have multiplication and division in it. So it looks very similar to direct variation, but you do have the multiplying component, and we always want to solve this for k so that we have a formula we can use later. This could also have squares and square roots and things like that as well, so be careful with that. We're just going to do one example here. This one says y varies jointly as x and z. Again, look for that keyword jointly. I always find it's good to write that setup first, even though it looks like you're just setting the same things equal to each other, because then it makes it easier to plug in from there. So we're going to do 80 over 5 times 8 on the left side. Equals, we're going to be finding y, so we don't know that. Find y when x is 16 and z is 2. So y over 16 times 2. And then you'll want to simplify that probably a little bit. Do your cross multiplying. You can do simplifying how you want. So you could cross multiply at this point. You could simplify the 80 over 40 and then cross multiply. However you want to solve this, your final answer should come out to y is 64. So those are your 3 types of variation and the basic problems that go with them. That should help you with completing the front and back of that first page on your practice packet. The next video we'll look at how we'll do this again with some application problems.